Okay, let me know when you start recording.
Yeah, already start.
Okay. Okay, so no questions about this part, right? Okay, no problem. I'll just move on. Okay, so when you want to test user events, then there are a few ways to do it. But I've seen an article from the creator of the library that says that the best practice to do right now is actually using the user event from Testing Library. So with the user event, you have different functions that you can use for acting like a user. So click, double click, type, upload, and so on. So this is very easy to understand. So I'll just go over it unless you have questions. So for handling asynchronous code, you can use wait for. So if you need to wait for an element to exist in the DOM, you will await and then use this function wait for. And then if you want to check the other way around, then you can wait for an element to be removed. How to update props of a rendered component? You use this function called re-renderer, which is also from the testing library. And you render your component first with the prop that you want. You do your assertion, and then you can re-render the same component with a different prop, and then do other assertions. Okay, now let's move to the mocking part, which is extremely important in testing, and any testing library or any whenever you do testing, you will have to handle mocking. So this is an essential part of testing. And there are all these words: mocking, stubbing, double, face dummy, spy, which kind of refer to similar things, but they're not identical. So sometimes it can be quite troublesome to understand what someone means when they say mock, because different library maintainers use different words sometimes. So they might say stub for mock or the other way around, and so on. But to explain, like the mock, stub, and spy are actually very similar. So a mock is an object on which you set expectations. So for example, you have a function that you are mocking, and you want to check that the function has been called, and that has been called with some arguments, and with which arguments, and what the function has returned, and so on. So that's the expectation. So that's when you call it a mock. But you can transform it in a stub so a stub is also a mock, but it's a little bit more than a mock. So it also allows you to create a different implementation of a function, for example. So it provides predefined answers to method calls. So let's say you have a function that you are normally using in your code, but sometimes you don't want that implementation because you just want to test other elements, other things in your app, and you don't care that much about that function. You can mock it, and that means it will return undefined. So that function won't, it will still be called, but not the original function. It just will call the mock that you defined. Or you can stub it, and the function will return the value that you provide to the stub. And the third thing, which is also kind of a mock, is called the spy. The difference between a spy and the others is that a spy doesn't replace the implementation of the original function. So when you call the function, you still call the original function, but the spy just spies on what that function does. So when you do mocking or stubbing, you replace the implementation of the function. When you do spy, you just have a look at what the function does without changing its implementation. Is it clear? Okay, I'll move on. So the other three words, dummy, fake and test double. So dummy is usually a placeholder required to pass the unit test. A fake is simply a dependency. So sometimes people, when they are talking about mocking, stubbing, and spying, they put them in the same bucket and they call them a fake, or they call them a test double. So they're pretty much the same. The only difference I think it is from, in some people's view, is that the spy maybe doesn't, it maybe is not included in the fake part, because the spy is not actually a fake, it's still the original implementation. But when they say test double, they refer to all the previous things, okay? So let's see some examples, maybe it will become more clear. So as I was saying, the mock replaces the implementation of a function to help capturing calls to it, and the parameters passed and set different return values. So mocking is a technique to isolate test subjects by replacing dependencies with objects that you control and you can inspect. That's why you do mocking, because you want to have control over it. So the goal for mocking is to replace something we don't control with something that we do control. Sometimes people refer to mock functions as spies because they let you spy on the behavior of a function that is called indirectly by some other code rather than only testing the output. In Jest, you can create a mock with jest.fn. If no implementation is given, then the mock function will return undefined. So actually in Jest, refers to all of these three elements. So mock, stub, and spy, they call all of them mocks. So when you see mock in Jest, you know that they refer to all three of them. And I'll show you how you can make the difference between one and another. So when you call just.fn, this will return undefined because there's no implementation given. So here you have this, you have the function append in your code that you want to test, but you don't really want to call the original function because maybe it does some expensive computation that you don't want to have in your test because it will slow your test down. So you mock it with just fn, and you call it with some variable, with some argument here, and then you can make assertion on it. So you can assert that mock, that function to be an undefined value, and you expect that function to have been called and to have been called a certain number of times and to have been called with a specific argument. So there are three main types of modules and functions mocking in Jest. So you can, with just fn, you can mock a function. With just.mock, you can mock a module. So basically, just.mock does exactly what justfn does, but it does for all the functions in a specific module. So you can replace the implementation, let's say, of a node module like the file system, because you don't want to hit the hard drive, for example. So you use just.mock and you put fs as an argument, and all the functions called on fs, then it will be automatically mocked. And then you can also use just.spy on. So this helps you to spy or mock a function, and it's the same thing like the just.mock earlier, but it does an extra thing. It allows you to restore the original function. So this is an example for mocking a certain file, a certain module. So imagine this math.js has some functions called add and called subtract and so on. So basic math, but you don't want to call them because maybe there are some expensive computations. So you mock them, you mock the whole module with this, and then when you call add this behind the scenes, it actually uses the math module. So then you want to make sure that this do add actually calls the math.add function. Is it clear or not clear? Hello?
Yeah, I think it's clear.
Okay. So you can also spy on a specific module. So when you spy on the, let's say we have the same module math, and you spy on this module, and you can check this. You can replace, not replace. You can, yeah, you can replace with an implementation by using mock implementation, and you provide here your function, your implementation that you want. And then when you call the function add, you know that when this function will call the add function from the math library, it will actually return this part instead of whatever it was used to return. And then you can also restore the original implementation back. So once you restore it, then the math will add function will actually return what it used to return prior to being mocked. Okay, so you can play back and forth depending on what you need to do. You can use the original implementation, or you can use a mocked implementation that you provide in your test, whatever you need. So to mock API calls, you can, so here we import the Axios library, and we mock it because we don't want to actually make the API calls because they're very expensive. So we don't want to do it in our test. So then we provide to the get function of Axios some return value. So like, for example, we expect from the server to receive this data. Instead of making the API call every time we run a test, we just use a hard-coded value, which will make the test much faster, of course, and it will make the test not depend on the server. Because if you depend on the server, then I think you can imagine your test will broke for reasons that are not because of you. So you haven't changed anything in your code, but suddenly your test failed and you can't deploy. So that's a very bad situation to be in, right? So you don't want to depend on third-party APIs and so on. Mocking date is also it's also important because the date up now it's obviously changing all the time. So you can use there are multiple ways to mocking dates, but I think this is the easiest one and the most useful one as well, because it's more flexible. So when you use this jest.mock library, you can advance to specific dates that in your tests, and then you can make your assertions and clear the date as well.
Oh, this is time traveling, right?
You could name it time traveling, yeah. Yeah,
Right.
you can name it time traveling.
Oh,
yeah.
this is much easier, because in Java you have to expose a clock instance inside your class and then make it exposed to unit tests, and then a unit test you have to use the clock instance to time travel, and then all your date now, everything must use that specific clock instance to run.
I see. Okay. Yeah, I think it's much easier with this library. Yeah, there are other ways of mocking dates, but they are a bit more difficult to use and not as flexible as this one. So I would recommend just date mock, for example. For timers themselves, when you use set timeout, set interval, and so on, you can mock timers with Jest itself offers these helper functions like use fake timers, run all timers, run only pending timers, advanced timers by a specific amount of time. So you could consider this time traveling as well and clear timers. So, but this doesn't refer to, this refers to the timers like set timeout and so on that are specific to JavaScript, I think. Now, when you test async code, there are also multiple ways of doing it with Jest, but I think this one is the most easy to read and understand. So you use async await and you call your function in expect, and then you can use results or reject. So you expect results to when the async code resolves, you expect the value to be this one, or when the code fails, when the promise rejects, you expect it to throw this error. So here you can use either a string or you can use a specific error as well, an error type instead of a string. And I think you can also use regex as well. So to mock specific node modules, you can, because you want to reuse the same mocks in every other place. So imagine using the file system, you definitely want to mock it like every time. I think there's no real reason, no good reason to not mock the file system. So because of that, you can use a specific file just for that mock. So you can, at the top of the project, you can have a mocks folder, __mocks __, and then you provide the mocks that you want to reuse in your tests. And from what I remember, even if you don't want to use the mock in a specific test, then you can, you just offer some function like unmock or something like that, so you can still do it if you need it. Okay, so when mocking the methods on the window object, this is the way to do it. So you define a property on the window object itself, and you specify the property name here, and then you specify the value and so on. Now, when mocking ES6 default exports, you need to use this. Actually, so this, as you can see, I'm providing a return value here. So I'm transforming this function from a mock to, what's the name? All these namings. You transform it into a stub. So that's the difference, for example, from a mock to a stub. So here, if I don't provide any value, this will return undefined. It will be just a mock that I don't care about the value. If I provide the value, I transform it into a stub, and it will use this value that I'm providing. And here in this case, I'm stubbing an element, a React element, so a React component that is exported with default. So it has a export default current weather. So to mock this, I need to use to stub it. I need to put the default here and ES6 module true. Now, mocking sometimes can become quite complicated in your tests if you have many dependencies. So Jest offers a lot of helper functions, which might be intimidating at first, but I'm going to explain a few of them to make it easier. So when you use jest.fn, so this part is basically the mock part, like I was saying earlier, but then you can either use mock return value and provide value for the mock to return. So you basically transform it into a stub, or instead of mock return value, you can actually put the same thing here in fn. So you can put a function here that returns the default and is going to do the same thing. So many ways to do the same thing. But if you want to mock different values at different point in time, then you can use mock return value once. So as you can see, when I call first time, this is going to be return the first element here. Then when I call the second time, it's going to return the second element here. And then all the other times it's going to return the default value, which I provided with mock return value, or I can provide it right here in the function. Is the same thing. Okay. So the difference between mock return value and mock implementation is that here I can actually have a function and create all sorts of crazy implementation depending on what I need, and then return the value. Here I'm just returning a hard-coded value. So like I was saying earlier, this function you can actually use inside here as just FN, and is the same thing as using mock implementation. And similarly, you can mock the implementation once, and it's very similar to what you've seen earlier with mock return value once. It's just that you provide a function instead of a value. Okay, and then you can, for async stuff, you can use mock result value, which is actually syntactic sugar for using mock implementation and using the promise dot resolve on it. So this will return 43 in this case. And of course, you have mock result value and mock result value once, and you have mock rejected value and mock rejected value once. I'm sure it's you can extrapolate and understand the other cases as well without me explaining. If you want to return this element in JavaScript, you can use this helper function. Okay. You can use mock name. This is actually very helpful for when debugging. So you'll have at some point sometimes a lot of mocks in your tests. So if your mocks don't have a name, might be a bit more difficult if them fail, or even if one of them failed. If you don't know which one failed, then that's going to be difficult to debug if you have a lot of mocks. If you provide it a name, then you will easily find out when your test failed, you will know exactly which one failed and why. And here you can get the mock name if you want to use it in your test as well. Now, another important thing is with clearing and resetting and restoring mocks, which all sound very similar. So the difference between having all and not having all, I think is pretty clear. Like clearing, restoring, and resetting all the mocks, or here you work with a specific mock. So this is used usually in the integration tests, for example. When you use mocks, you use a lot of mocks over and over again. Then use the after each from Jest to reset all the mocks from each test. So what this means is that you want to make sure that your tests don't depend on each other. That's very, very important. So if your tests start to depend on each other, then it's going to be extremely difficult to debug, and your tests will fail a lot of times for no good reasons. So that's why you want to make sure that you reset, you clear, or you restore your mocks. So clear you use when you want to clean up a mock's usage data between two assertions. Reset does the same thing, plus it removes any mocked return values or implementation. So basically you use this more with mocks and you use this more with stubs. So that would be the difference, and you use this with spice. So restore does the same thing as the other one, as reset, plus it restores the original non-mocked implementation from spy on. Any questions before I move to end-to-end testing? Okay, no questions. Let's talk a little bit about Cypress. So Cypress is an end-to-end testing tool. It's actually I think the best end-to-end testing tools currently. It works with Chrome and Firefox as well, and with other browsers too. So what's good with Cypress is that it offers a lot of features that other end-to-end testing tools don't offer. So it offers time traveling. So what that means is you run your tests, and then Cypress takes snapshots of your tests, and you can go back and forth throughout your tests and debug much easier than in other testing tools. So this time traveling part is a little bit similar to the time traveling that you have in Redux, quite similar. Then it offers debuggability. It seems to be much more useful than other tools as well. It offers automatic waiting, so no need to do async await and stuff like that. Cypress will automatically wait for things to happen. They also offer, of course, stubbing and spying and so on. So what that means is that with Cypress, you can also do unit testing and integration testing as well. But it's not, they say themselves that Cypress hasn't been built for that. So it's the best end-to-end testing, but for unit testing, integration testing, you might want to use other tools like the ones I previously mentioned. And one other very, very useful stuff is that they offer screenshots and videos. So when it will be much easier to find why some tests fail and to debug them as well. So end-to-end testing are usually end-to-end tests are usually quite expensive. For example, unit tests run in few seconds, maximum 10 seconds maybe. Integration tests, so per test. So integration tests usually run like dozens of seconds per test, and end-to-end tests can become minutes. So and that's why you want to make sure that you don't need to rerun the whole suite again and again, and you want to make sure that it's easy to debug. So having all these features, it's actually very, very useful. And another important thing is that they offer consistent results, better than Selenium, for example. So the tests are less flaky. So you have more trust in your tests because they don't fail for reasons that are not supposed to. So before Cypress, you were to use like choose a framework, take an assertion library, install Selenium, have a Selenium wrapper, adding some additional libraries for mocking and spying and so on. So a lot of tooling that was making a hard time for developers for configuration and so on. So with Cypress, you just install Cypress and that's all you need. So basically, because behind the scenes, it actually has already a testing framework. It has Mocha. It already has Chai as an assertion library. It already has sign-on as well for mocking and stubbing and so on. So similarly with Jest, it offers a lot of tooling all by itself. And if you are gonna use one tool, actually it's gonna be easy for you to understand other tools as well. So once you do testing with Jest, for example, you will easily understand Cypress as well, because behind the scenes they're using very similar assertion libraries, very similar testing frameworks and so on. So it's just some different syntax sometimes, but it's very easy to understand once you get used to one of them. So just to show a short example with Cypress, with Cypress you use CI for Cypress instead of just like you've seen earlier. So you can visit a page and then you can assert that you can assert that the page contains something that has a type, and then you click on it. So if this is a button, you'll be able to go to a different page. So then you can check that the new URL is the one that you expect, and you can check that there are some elements in the page that you need. So, and I won't cover too much of Cypress because the documentation itself is actually very, very good. So Cypress is done by a company and they invest heavily in the documentation. It's quite easy to understand. They have video tutorials as well and so on. Now for an example of arranging your test with Cypress, For example, in the before, you see already that you have similar things like describe, and assertions you will see are very similar as well. And now instead of test, you use it, but it's the same thing. So in before each, you can prepare your test. So you can reset your database and seed your database to have some elements in it. And then you can create a post request to your API to add something in the database. And then you can check whatever you need to check after you have done everything you need to do in the before each. Now, when you test pages that are under authentication, which is actually very important in end-to-end testing, and in our case as well. So you visit the login page, you get the input, the username input, and you type the username or the email in our case. You get the password, you type in it, and then once you type in it, you enter. So you click enter with this as well. Then you expect to be on a different page, and so on. And you can check other things like the cookie to be set, and that some UI element is present that you expect to see only after you log in. So you do this this logging part. So this is going through it like a user would. So you go through the UI to authenticate. But because this is expensive to build up state, Cypress recommends to do it only once to check the functionality is correct, but in other tests to programmatically log in. So you just do the request instead of building the state over and over again, of acting like the user on the same thing that you already know that it's working. So this will save your test time to make sure that it loads faster. Okay, so that's all I have for now about Cypress. If you want more about Cypress, if you want me, I can do another time some other presentation about it. But if you think it's easy to understand, then you can just go through the documentation. It's quite good. So for super test, which I only have one slide with it because it's also very easy to use. I've used this for backend testing, for backend end-to-end testing. So you end-to-end test your APIs like an API consumer would. So this is not UI testing, of course. It's API testing, like you have this API that you call here programmatically, and you assert different stuff to expect you receive some specific response and so on. So this is an example that when I've used Supertest in the past. It's in a Nest.js application, so a lot of things are happening behind the scenes that no need to explain because it's specific to Nest.js. So I'm creating an app here based on Nest.js requirements, which Nest.js uses a lot of dependency injection. So there's quite a lot of setup behind this function as well, which there's no need to show because we won't need it in this project. You only need it for Nest.js. And then after each test, I restore the mocks, and then I remove the test user, which I created behind the scenes in this function, and then I close the app. So then when a test runs, I will have already a test user created. So I log in with that test user. I call the API here, and then I expect the server to, when I call the API and I send the user, oh, sorry, yeah, I remember now. So this part actually introduces a user in the database. So behind the scenes here, I'm introducing the user in a database and creating the user. And then when I request to the API, to log in with that specific username and password and the wrong password. So the user, I do have it in the database, but I have it with another password, then I expect to receive from the server or an unauthorized error. So this is how you use Supertest for API testing, for end-to-end API testing. So only a few slides before I finish. What to test and what not to test is actually quite important. Sometimes, theoretically, you might be inclined to test everything, but that's not helpful because you'll waste a lot of times. So you shouldn't test literally everything. So what needs to test it with higher priority are utility methods that you created. So maybe something that you reuse over and over again in your code. It's extremely important to use it to make sure that you don't accidentally break a lot of parts of your app. Other complex implementations like algorithms and so on, also very important to unit test and to check, to assert many edge cases and check that your implementation handles all the edge cases that you need. Any core business logic that is extremely valuable or critical for the business, or if it might lose the business a lot of money if it's broken, then it's extremely important to test. Like, for example, for an e-commerce store, it's extremely important for the checkout to be working, otherwise the business is losing a lot of money, right? So that's something that you would definitely want to test. Any services that are high risk, any common user interactions, so logging in, logging out, and so on, any important forms in the app should be tested. And error cases that you expect to happen frequently, like for example, in a login screen, you should test what happened when the user provides an incorrect password. So you want to make sure that you handle these cases. You show some messages to the users and you let the user know what needs to change. You also need to integrate different elements. So if you do a lot of unit tests of different functions or different components, that might still not be enough, because you might have failing parts when things interact with each other. So in unit tests, you will mock and stub a lot of things, but you want to make sure that they work together correctly. And there is such thing as over-testing, which we're definitely not there yet, so no need to worry about that right now. But just to mention what not to test is JavaScript and Node.js core functions. You shouldn't test because they have their own developers and they do their own testing and so on and so on. So you don't need to test that. Any third-party libraries as well, even if sometimes you might depend on them, of course, you still shouldn't test them, because that's going to be crazy. Like having an npm module might have other hundreds of modules. Imagine testing all of that. You can't do that. Any external applications shouldn't be tested by yourself. Should be tested by their own developers. API calls most of the times should not be tested on the front-end side. So they should be tested only if you're doing API end-to-end testing. Otherwise, you should stop them, mock them, and so on. Database operations, you should avoid most of the times as well, unless you're doing end-to-end testing, because these database operations and the API calls and touching the file system as well, they're very slow operations. So you want to make sure that your deployment doesn't get stuck for hours because you're handling all this stuff. So you want to introduce this only in end-to-end testing, which will have only a much lower number set of testings. And trivial methods that don't have any logic, like just simple, very simple getters and setters, for example, shouldn't be tested. So if you just want to have more if you want to code to have the code coverage for this part as well, you can use some comments, some hacks to tell Jest not to check this, to include it as if it was tested as well, which I'm not going to provide now because I don't want it to be abused. Any code that is throwaway or placeholder code shouldn't be tested. You shouldn't waste your time doing that, obviously. So if you're in a startup that is doing just an MVP to show a very fast MVP to show some stakeholders, and you know that's going to be very hacky code that you won't need later on, don't test. No need. Okay. Testing best practices is tests should be pure. What that means, they should have the same outcome on multiple runs. So they should not be flaky within other words. So you want to make sure that your tests fail because you have some bugs or because you have changed your implementation and you haven't updated your tests, but you want to make sure that your tests don't fail because of some third party or any other reason that doesn't require you to change anything. So best is to mock API calls, third-party libraries, timers, dates, random values, so like math.random, for example, hitting the disk and so on. Related to the previous part with tests should be pure is also that tests should be resistant to UI changes. So that's why I introduced React Testing Library instead of other libraries like Enzyme, for example, which the way you do testing with Enzyme and other tools for UI are actually very, very dependent on the implementation. So most of the examples that I've seen online with these tools are actually testing maybe more than 90% of the time they are testing the implementation. So if your implementation changes, then you'll have a hard time updating the test as well. Whereas with using React Testing Library, your test will fail only because if you correctly use the selectors, your tests will fail only when you change the UI. Only when you actually have a problem in your implementation. So all tests should be independent of each other. So like I've shown earlier, reset all mocks, reset. I wrote in the same one. So reset, restore, and clear all mocks should be used. You should name your tests wisely. The names should say exactly what the function should do, but not how. So this naming will serve you as documentation. So when you run the SIP tests, you're gonna see very easily exactly what is tested and so on. So when you find yourself mocking the same function over and over in multiple tests, don't do that. Just you can just make a default mock when you use the mocks folder. Okay, and this is very important. Treat your tests like the rest of the code. Keep them clean and simple and easy to understand, and also maintain and code review them. So why is this extremely important? Because let's say, first of all, let's say you have no tests at all, then you know that you're gonna, the more complex your app becomes, you know that we're gonna be more and more afraid to do refactoring. Because you're afraid of introducing bugs and spending a lot of time on fixing those bugs. So that's why you start doing testing, right? So let's say you do testing, let's say you have a high coverage, maybe even 100%, but you have your tests so complicated and so difficult to understand and to read that at some point in time, you become so frustrated that you don't create new tests anymore, or you don't update your tests anymore, and you leave it, and you basically come back to the same situation like you were before. So that's why it's extremely important to create to keep the test clean and simple to understand and treat it like your other code is as important as the other code that you create. Also important is to create tests from the start, which is easier and will enforce your code to be more modular, easier to understand and maintain. Now, TDD can be a big subject that I'm not gonna touch much today. That only one thing that I want to mention that, okay, sometimes you might find it difficult to create a test first. That's okay. It happens actually to everyone. So you might create your implementation first. But just to make sure that it's easier for you to create tests, just make sure that you don't create too much of the implementation before you start writing tests. So if you do it step by step, and you create tests step by step as well with your implementation, it's going to be way easier to create the tests. Because if you've tried testing before and you went into a new project created by someone else, you know how difficult it can be to create tests on already existing code. So TDD can, in my opinion, can be done even if you don't do the test first. And what I mean with this is that, for example, I create some implementation. I create a function where I implement something. Then I create, let's say I create my test after the function, and I create those edge cases that I want to test. And then my test passes, I see green, but I'm not sure if I correctly have my test or not. So I can go into my implementation and make sure I break something just to check that that my test fails. So I want to make sure that the test fails when I have a bug in my implementation. So in a way, you could still name it test-driven development, because I'm checking that my implementation breaks. I'm checking that my test fails when my implementation introduces bugs. Otherwise, if you don't do this step at all, then you might have a test that passes, but it actually passes for no reason. Like I can create a test like expect true to equal true. How is that useful? Not useful at all, right? So like this, you can create some tests that you think they are testing the implementation, when actually they are not, and they're just returning true for other reasons. So don't create fake or poor tests just for increasing coverage. That's not helpful as well. So it's just wasting you time for no good reason. So just to recap before we stop, we talked about testing, why testing is important, difference between different type of testing methods, difference between different type of testing tools. We talked about test matchers and extensions, and how to create UI tests that are independent of implementation. We talked about how to test user interaction, about mocking, stubbing, and spying, and what's the difference between them. And we also talked about end-to-end testing, which can be of two types, like UI end-to-end testing and backend API testing. We talked about what to test and what not to test, and testing best practices as well. So let's hear any questions that there might be. Is everything so clear, or did I just put everyone to sleep?
Oh, no question. I'm sorry, I checked in just recently, so I'm not sure whether you cover or not. Actually, my most interested question is that can actually all this be bundled and then packaged as a CI or deployment test before it goes inside the version control?
So you want to make sure that your tests are run when you do the CI/CD process. Is that right?
Yes. Definitely.
Yes, of course.
And we are going to do that, right?
Yeah. So I already created the testing part. Now I know that Sonlang is working on a different CI process. So to move away from the Git one, if I understand correctly. So we should take it from there and see what he suggests and so on.
Okay, great.
Uh,
Yeah, that's a question.
Yeah, yeah, we just moving away from the GitLab CI runner. I think the actual testing script is still the same.
Okay. Yeah, well, actually, because in GitHub are already the CI process already calls Jest, so already calls the Jest runner, and this runs all the tests that we already have in the code. So it should run all the new tests that I created as well.
Okay.
Okay.
That's good to know.
Other questions?
Hello, thank you for your sharing. I have a question is, according to my previous experience to test the web UI in the using the Selenium, mostly I was facing the problem that if I want to test with user actions as well as the UI components, sometimes, especially for the the UI components, it's need to have some async requests from other servers. So maybe it's not rendered properly, but my Selenium script already done the check. I don't know whether I described my problem well.
So I think I understand. So with Cypress, you can wait you can wait until an element is visible on the page, for example, if that's what you need.
But sometimes it will cost a lot of time because in order to wait until the elements is visible, otherwise we will set a wait time like several seconds. But in this case, all the test cases will lasting a very long time, especially for our current situations. Some pages maybe need over 10 seconds to render.
So you want to wait for an element to be on the page, but in the same time you want to make sure that tests are not too slow. Is that right?
Yes.
Okay, so with Cypress, I know that you can run only specific tests that you have in your test suite. So if you don't want to run them, all of them, you can just run one test suite. And in that test suite, you can make sure that that Cypress waits for specific elements to be visible on the screen.
Okay. But from our websites, because we are not full of user actions, mostly are just the chats, render chats. So if I'm doing the UI testing, what kind of check expectations should I done?
Okay.
Because expect for we are using the all the input data as we mocked, then we are expect the UI are rendered in as the same. But otherwise, if we are using the data from the server, then I think every time the chat will be different.
Yeah, so in that case, most of the elements have a loading UI state. So if you wait for the element to move from the loading state to be existing on the page, then in order to do that, you can select like using a CSS selector, but you select for that element. So that element doesn't exist in the page when the UI is low, when some API is loading with the data, is coming through with data, then the element itself will show a loading animation. So you want to make sure that after that UI animation is replaced with the element that you want on the screen, then that element should have a class, either a class or a data test ID that you can use to make sure that Cypress waits until that element with that class or that data test ID is visible on the page.
But that's only can be checked for the UI elements visible or not.
Okay.
But we cannot
Okay.
guarantee the curve inside the elements, right?
Let me see. Okay. Well, yeah, I'm not sure how to get the elements inside of the chart. It depends on how they are built, and yeah, it depends on how they are built. But what you can do actually, because as Cypress recommends, is you shouldn't do API calls in your end-to-end tests either. So what they recommend is doing API calls just for the login, for example, to make sure that the functionality works, or to put them in a different test suite just to make sure that the API, the server still works or whatever. But other than that, when you're testing the UI, it's easier and faster to provide the mock. So you provide the value that the server would normally return. So you don't do the API call at all.
Okay, thank you.
Other questions? Anyone else?
I don't think so. I tell you what, since you have established yourself as the leader in this, I'm very sure if we have any questions, we know who to look for.
Sure.
Thank you very much.
And
Yes,
just upload let's upload the recording on Confluence or share with the rest. Yeah, so maybe later I can watch it. Yeah.
Yeah, I'm gonna give you the link to the PowerPoint as well, because I think that's gonna be quite useful too. And you can for the front end, you can also check the HVAC overview branch. So, or maybe once that's introduced in master, integrated in master, then you can check the tests I've created over there for some examples as well. Okay. Well, okay. Thanks for your time. If there's nothing else, we can stop here. And yeah, we can put the recording, upload them. And if you have any more questions later on, just let me know.
Thank you.
Okay, thank you.
Thank you so much, Gabriel. Thank you. I appreciate it.
Thanks.
Thank you.
Thank you.